In the previous clip, we have assigned the main view model to the data context property of the main window. Now we can go to the main window SAML file and we can create the user interface and bind to the properties of the main view model. But the first thing I want to do here, I want to set the font size on the main window to 20. The main window contains by default a grid. That's a layout panel that arranges its elements in rows and columns. If you want to know more about layout, I can recommend you my course SAML Layout in Depth. On the grid that we have here, we want to define two column definitions as we have the navigation on the left and the details on the right. So let's just use the grid column definitions property and let's specify a column definition with a width of 200 for the navigation and another column definition for the details with a width of star. Star means this column definition uses the leftover space. As the star is the default value for the width property, you don't have to set it. Now let's add a list view here that we use as a navigation. We place the list view in the first column that has the index 0. But as also this is the default value, we don't have to specify it. Let's bind the list view's item source property to the friends property of our main view model that is in the data context. We also bind the selected item property on the list view to the selected friend property of our main view model. And we use a two-way data binding here so that the value is also written back into the view model when we change the item in the list view. The last thing I want to set on the list view is the display member path property. We can use this one when we have a complex object in the list view like a friend. It allows us to select the property that we want to display. In this case, we want to display the first names of the friends. Now in the second column of the grid, we want to define the details. To do this, I just nest another grid that I place at grid column with the index 1 in the outer grid. Now I define some row definitions on that grid. Let's create a row definition with a height of auto. Auto means the row definition is automatically as high as the highest element in that row. As we will have 3 labels and 3 text boxes for first name, last name and email, I need 6 row definitions. And I also create another row definition here with a height of star. So this row definition takes the leftover space. The star is also the default value here, so you don't have to set the height property if you want to use a star. Now let's scroll down a bit and let's create the elements in that grid. So I place a label here and I set the content to first name. On the label I also set a little margin, 10 on the left, top 10, right 10 and bottom 0. Then I create a text box and I place the text box at grid row 1. We need to bind the text property of this text box to the selected friend's first name property. And we use a two-way data binding, and we also say that we want to update the source object when the property is changed in the text box. By default, a text box will update the source when it is losing its focus, but we will update the source as soon as the user is changing the text box. Okay, let's add a line break here. On this text box I also set a little margin, 10 on the left, top 0, right 10 and bottom 10. So we are done with the first label and the first text box. I just copy this thing and I paste it again. On the second label, I specify the content last name and I want to define a margin at the top of 0. Now there is also a shorthand syntax. You can also just write 10 and 0. Then it will use 10 on the left and on the right side and 0 at the top and at the bottom. On that label we need to define the grid row. It's grid row 2, and on the text box it's grid row 3, and we need to bind to the last name property of the selected friend. Now let's copy this again for the email. So the label has the content email, and we also bind to the email property of the selected friend. And the label goes into grid row 4, and the text box into grid row 5. Now let's save this. Let's take a quick look at the designer. And you can see it looks pretty well. We have 3 text boxes and their labels. Let's switch back to SAML. Maybe you ask yourself if you're familiar with layout in SAML, why I didn't use a stack panel, because all the elements in this grid are just stacked vertically. Now this layout allows me later to place another row definition at the bottom where we can put, for example, a save button. This wouldn't be possible with a stack panel. Later in this course we will do exactly this. We will add another row definition to place a save button at the bottom of this grid. But for now, let's just remove this row definition again. Now with this user interface defined, let's try to run the application. The build succeeded, but we get an exception, a SAML parse exception. It says, no matching constructor found on type friend organizer UI main window. Of course, the SAML parser is not able to call this constructor of the main window that requires a main view model instance. So we need to fix this. Let's open up the app SAML file, and here we see a property startup URI. This defines the window that is started with the application. We just remove this property and instead we use the startup event. I just hit enter to create an event handler, and I right click it and I say go to definition. Now I'm in the app SAML CS file. Inside of this event handler, I can create a new main window instance on my own. The main window constructor requires a new main view model, so let's specify this. And let's add a using directive for friend organizer UI view model. And the main view model itself requires an iFriend data service. So let's pass in a new friend data service. And I need a using for friend organizer UI data. Now we have created the main window and we can display it by calling the show method. Now let's see if the application works. Here we go, the application comes up and we can see the friends on the left side in the navigation, which is our simple list view. When I select a friend, the selected friend property of the main view model is set, and the text boxes on the right are displaying the details of that selected friend. So now I can just navigate through these friends. I can even define an email address here. And when I navigate to another friend and I come back, you can see the email address is still here. When I change the first name, you can see that the first name also changes in the list view. So now our little application is working. But there is one thing I don't like. It's this piece of code. Instead of injecting all the dependencies manually, we should use a dependency injection framework. And this is the last thing that we do in this module. In the previous clip, we have created a main window instance by passing a main view model to the main windows constructor and by passing a friend data service to the main view models constructor. Taking the dependencies as constructor parameters is a good idea. For example, for the main view model, you could pass in a fake friend data service that you use in your unit tests. If you wouldn't have such a constructor parameter, you wouldn't be able to pass in a fake data service. But now the problem is, whenever you change a constructor of one of your classes, you need to adjust this piece of code, and that's bad. That's the reason why we will introduce now the dependency injection library called AutoFag. With AutoFag, we can just resolve a main window instance from a container that knows how to create all the dependencies. So let's switch to Visual Studio and let's set this up. The first thing that we need to do when we want to use AutoFag, we need to add the NuGet package. So let's browse for AutoFag. Here is the package. Let's just install the latest stable version. Now let's add a startup folder to our UI project. And inside that startup folder, I create a class that I call Bootstrapper. Let's make this class public and let's remove the unused usings here. The Bootstrapper class is responsible to create the AutoFag container. The container knows about all the types and it is used to create instances. So let's make a public method that returns an iContainer. We need a using directive for AutoFag. I call the method bootstrap and inside of the method I create a new container builder. On the container builder, I can register my types. So I can say, for example, I want to use the friend data service whenever an iFriend data service is required. So this means the container knows now when an iFriend data service is required somewhere, it will just create an instance of the friend data service class. With AutoFAC, I have also to register the concrete types that don't implement an interface if I want to resolve these concrete types from the container. So let's also register our main view model. And we just say here as self. And I do exactly the same for the main window. Now we can just create the container by calling the build method on the container builder. And we return the container from this bootstrap method. Now let's go back to the AppSaml CS file. Here we can create a bootstrapper. And we can create a container by calling the bootstrap method on that bootstrapper. Now we can get rid of this piece of code. We can just say container resolve. But as you can see, the resolve method is not here. It is an extension method that lives in the namespace AutoFAC. So let's just type resolve and I press escape to close IntelliSense. And I want to resolve the main window. Now I press Ctrl dot and you see a using for AutoFAC pops up. And now the red squiggle disappears. So we are done. We have set up AutoFAC. The resolve method will go to the main Windows constructor. It sees that it has to create a main view model, and then it will go to the main view models constructor and it sees that it has to create an iFriend data service. Because of the information that it has in the container, it knows that it has to create an instance of the friend data service where this iFriend data service is required. Now let's see if we can still run the application. Our application comes up and it works as before. So now we are done with this basic user interface layer. In this module you have learned about the basics of the MVVM pattern. You have built a UI layer in the Friend Organizer application that consists of a view model and a data service. The views constructor takes a view model and the view models constructor takes a data service. You have learned how to set up AutoFAC to use it for dependency injection. So with AutoFAC, the view model is automatically injected into the views constructor and the data service is injected into the view models constructor. Now the basic UI layer is done. In this module, we have returned fake data from the friend data service. Now let's set up Entity Framework so that we can load data from SQL Server. Welcome to the module Setting up Entity Framework. My name is Thomas Claudius Huber. In this module, you will learn how to set up Entity Framework code first to create and seed a SQL Server database. Then we will extend the Friend Organizer application to load data from SQL Server by using Entity Framework. Before we start, let me show you the module outline. You will start this module by planning the data access layer of the Friend Organizer application. Then we will create and seed the database for the Friend Organizer application with Entity Framework code first. Finally, we will use Entity Framework in the Friend Data Service to load the data for the Friend Organizer application from SQL Server. Let's start with the planning of the data access layer.